Hello, stats people. This is going to be your little intro video to chapter 20. We're talking about statistical inferences with hypothesis based on proportions. If you are a geometry student, why are you watching this? Stop. This is not for you. Leave. Okay, so I actually want to use a recent event in the media, in the news. Was the Iowa caucuses where Bernie Sanders and Hillary Clinton had tied, and they had to flip a coin to decide who the winner was. And they had to do this 6 times. They had to flip the coin 6 times, and all 6 times, Hillary won. And people were in an outrage, and they were like, the coin was a trick coin, and it was fixed to land on tails. And there was, how people get with politics. It was very heated discussion. So what I would like to look at first is just the idea of flipping a coin 6 times and it landing on tails or heads, whichever, tails, 6 times in a row. So let's say I flip the coin once. That's a 1/2 chance. That gives me a 50% chance, right? We'll just call that my p-value. And then I get a second tails. That's 25%. And then I get a third tails, and that ends up being about 12.5%. And then I get a 4th tails in a row. That's about 6.25%. And then my 5th one, that's about a 3. I guess I'll be specific here. So the probability of getting 6 tails in a row is about a 1.56% chance of that happening. So it's not statistically impossible. It can happen, but it's very, very unlikely. So now what we're going to look at is the claim of, was it a trick coin? Is it very unlikely that, this had happened? And around this time, these numbers is when you start to get a little suspicious. Like if you flip a coin 3 times and get 3 tails, you're kind of like, no big deal. You're not really surprised by it. But getting 6 tails in a row, that's a bit of a shock. A little bit of a surprise. So what we're going to test now, and this is what this whole course leads up to, is these hypotheses situations and these claims. And if you work in the real world and this is your job and you work for a company, you have to investigate these situations and run these tests to make these claims or support these claims or reject these claims. That's what it all comes down to. And pretty much for the rest of the school year, we're going to be looking at this 4-box model and working with different numbers and different scenarios to look at supporting claims. So it's a 4-step process, and the first step of what you have to do is to define your parameter and state your hypothesis. So the parameter stuff, that is just your mean and standard deviation, using the same formulas that we did for chapter 18 and 19. So just as a quick, if I was using a coin flip scenario, that's 50%. Nothing fancy there. For the hypothesis, there are 2 things that we need to write. The null hypothesis and the alternate hypothesis. The null hypothesis is denoted as H sub O. The null hypothesis is when you're saying that nothing is changing. It's kind of just like plain and boring, and nothing has changed, and I don't think anything is different. So if I'm talking about my coin and is it a real coin or is it a trick coin, if I'm just under the assumption that this is a normal coin, so that the probability of getting heads or tails is 50%. My alternate or my claim, so say I'm working in the Bernie Sanders corner, and I'm like, nope, Hillary Clinton used the trick coin. My claim then, or my alternate hypothesis, is to say that the probability of that coin was not 50%. So there's actually 3 scenarios that can happen in an alternate hypothesis. You can say that it's not equal, you can say that it's greater than, or you can say that it's less than. So if I was saying that the probability of it landing on tails was greater than 50%, I could investigate that if I wanted to. The notation of the alternate hypothesis is H sub A. So sometimes when I say write the hypothesis, we may refer to this as the ho-ha, the H-O, the H-A, ho-ha. So that's step one. Step one, we're done. Step two is the conditions and the procedures. So our conditions have not changed. They are still the same. Assume independence, assume random samples. We're going to check to see that NP is greater than or equal to 10, NQ greater than or equal to 10, assume less than 10% of the population, all coin flips. So yeah, all of those work. Now, granted, I didn't pick an actual N value here. Now, the scenario was they flipped it 6 times, but we're not really investigating that specific scenario because we would need bigger data because this would not have been met if just 6 samples were used. So we would need more samples. But let's assume that all 4 conditions are met. The last part of this procedure, all you got to do is write a little sentence saying, now the conditions have been met, therefore we will use a blah test. For this particular chapter, that blah part is going to be a 1 proportion z test. So in the last unit, we did a 1 proportion z interval. That gave us our confidence interval. The 1 proportion z test is going to give us the values and things that we need to help support our claims. So the mechanics aspect of it is now when you're actually going to run that test and look for a p-value. And then you're just going to show your work here. So this box here is basically just the work. And now a conclusion. I want you, before I show you what your conclusions are going to look like, I want you to think about jury selection and if you're in the courtroom. When somebody is on trial, the jury is trying to decide if that person is guilty or not guilty. And the whole thing is to be, you need enough evidence to prove them guilty. Otherwise, you have to say they're not guilty because there's not enough evidence. But notice that they never use the word innocent. And the reason for that is in a courtroom, you're not saying that when the person's not guilty, you're not saying that they're innocent. You're just saying, we didn't have enough evidence to prove you guilty. So you have to sort of be careful with your words there. Very similar situation when we're talking about our null hypothesis. And we're always talking about the null in our conclusion. We'll never actually talk about the alternate. We'll always talk about the null. So your options are to either reject the null or fail to reject the null. So we reject the null if we have enough evidence to support our claim. So when I reject this, I would say, nope, Hillary Clinton was using a trick coin because I had enough evidence to support that claim. However, if I don't have enough evidence to support the claim, we don't say we accept the null because it could be a trick coin, but we don't have enough evidence to support that it's a trick coin. So we would say we fail to reject the null hypothesis. So that just means that we don't have enough evidence to support it. And this is pretty much what you're going to be doing for all of these problems. You're going to be making these 4 boxes and kind of just doing each of the steps of the 4 boxes. So that hopefully gives you a little head start on Chapter 20. So when I see you guys next, you have a better understanding of the things that I'm talking about, and I maybe don't need to repeat all of this so much. Thank you for watching. Have a wonderful weekend. Bye.